Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the electric vehicle and different concepts related to electric vehicles. And we will also see how we can implement these models in MATLAB. In the previous tutorial, we have seen the charging port and different pins related to the charger. In this particular video, we will be having a look into a specific pin that is mostly being used to control the charging process or the charging current, and also used for communication between the electric vehicle and the charger. So as you can see here, we have a pin 2, which is basically called a control pilot. So basically it has multiple roles. If you consider a control pilot, then you will be having multiple states. So one state could be like the vehicle is not connected to any charger. In this process, it will tell the or it will signal that it is not connected to any charger. Then the next state is it is connected but not yet charging. It is ready to get charged. So you can charge it after this state. And at the end, you will have the charging process ongoing. And this will be repeated in a sequence, like as the charging is going on. So maybe charging will stop. So again, it will go to the previous state and then you disconnect the charger. So it is disconnected from the vehicle is disconnected from the charging station. So based on this, you can see the control pilot is able to control, and it is also able to control the current. So that we will see later on. So let's see like what are the states that are available in the control pilot and how it knows which state it is in currently. So if you see, there are totally multiple stages or states that are present for the electric vehicle charging port. So one is the state A, which indicates that the EV is not connected. So it means that electric vehicle is not connected to the charger. Basically, at this moment, it will show you a 12 volt as the indication. The second state is the state B. And in this case, the EV is connected, ready to get charged, but it is not yet charging. At that moment, you will be getting a 9 volt of supply or 9 volt detection in the entire process. So if it is at 9 volt, you will be able to know like it is ready to get charged, but it is not yet charging. Next is the state C. In state C, the electric vehicle is getting charged, and at that moment you will be able to see the voltage at the control pilot to be 6 volt. Along with that, there are also multiple error related states. So these are error related states. So EV charging vent required. So this is one case where you will be having the 3 volt as the reading from the control pilot, and at error state it will be reading 0 volt and control pilot signal low. So at that moment it will minus 12 volt as the output of the control pilot. So basically these states we will see in detail later on in subsequent video, but currently we will be seeing these states and how we achieve these voltages, that also we will see now. So coming to the circuit diagram, how the control pilot or the overall circuit diagram looks like for the charger. So here you can see you have the EVSC controller. So basically this is the charger controller, and this is EVSC connector. It is the port through which you connect it to the vehicle. Next is the vehicle inlet. So basically this is the inlet through which you put the charger inside. And again, then you will have a vehicle controller. So vehicle controller is the end part of the entire circuitry. And here you have multiple elements and switches. So this is a detector which detects like what is the voltage level. And this is also a pulse generator that is generating a pulse of 12 volt, which switches between plus 12 to minus 12 volt. And the frequency of the switching is 1k hertz. So with this frequency, it will oscillate, and based on these oscillations, we will be able to get the voltages based on different voltage drop. So these are the basic elements. And if you see these are female pins and these are male pins. So once you connect both the port, it will be getting connected and individual ports will be linked with the same male female port. So you will have multiple registers that we will see when it comes into the picture. We will also see how proximity pilot works in the coming video, same based on the circuit only. So coming to the first state over here, the state A. So in this state, the vehicle is not connected to the charger, and in this case, you will also get no connection. So these male female pins are not getting connected, and out of these the pin 4 is the control pilot pin, and as you can see it is not connected. And when it is not connected, if the switch gets closed, right, so at that moment you will be able to see a voltage drop of 12 volt through this 1k resistor. So if you draw the equivalent circuit for the same, so this is the equivalent circuit of this entire diagram, and you will have a 12 volt supply and you will have a 1k resistor, and over this resistor you will have a 12 volt voltage drop, and this is how it reads the 12 volt as it is not connected to the charger, the electric vehicle. Next is the state B. So in state B, it gets little bit complex. Now your switch is closed and you have 1k resistor that is there, and you will also have a 2.74k resistor that is connected to it. And overall, if you draw the equivalent circuit diagram in state B, it will looks like this. So here you have two parallel registers that are connected. One is 1k resistor, 1k resistor, and another is 2.74k resistor. Okay, and because of this you will get a current of this much amps in the circuit. And then with the help of this, suppose if you want to calculate the IR drop, so it will be approximately around this much 3.2 volt, and you will also get the voltage drop approximately 3 volt. And when you consider the drop in the voltage from 12 volt to 3 volt, you will get approximately 9 volt over here. And this is how this 9 volt is being detected in state B. And whenever you are at state B, you will be detecting this 9 volt. Next is the state C. So in this state, so the state will be achieved at multiple conditions. And like suppose if your battery is not having enough charge, then in that case it needs the charging process. So whenever the vehicle needs the charging to be enabled, basically the flow of current inside the batteries. So in this case, the state C will get activated, and because of this, you will be having the circuit like this. So you connect the switch and through this 1k resistor, as you already have a 2.74 resistor, and you will have a 1.3k resistor. So these, when you draw the equivalent circuit for the same, so then you will have this. And here also the equivalent resistance you need to calculate. So it is coming around 1.881. And with that, if you want to calculate the current, it is coming around 6.379. And if you just deduct this voltage, then you will be getting like around 5.621, which is approximately equal to 6 volt. With this, what basically you are getting in state B is the 6 volt, and this 6 volt is coming because this switch is getting closed. So this particular switch is getting closed and it is closing the circuit. So whenever this switch is not getting closed, what could be the scenario at the same time? So suppose you have 100% of your battery is already having the charge, so it do not need any charging again further. So with this, like, you don't need to do the charging process, but at that moment this switch will not close. But suppose also, like, your battery contactors are not getting closed, so at that moment you cannot do the charging process. So because of that, this switch will also not close. So there are multiple scenarios in which, like, if your charging process is not feasible, like not enabled, then in that case the switch will not close, and then you will not get the status of 6 in this particular case. So these are the three states in which the vehicle can be present. And if you see the overall summary, like how this entire process looks like. So initially you will have this 12 volt, which means you are at state A. So with state A, you will be starting always because vehicle is not connected to the charger. Then once you connect the charger, you will get into the state B, where you will be getting this 9 volt of voltage across the control pilot. This is state B, and with this, once you cross the state B, if the charging process is feasible, then 6 volt will be visible over here, and you will get pulse of 6 volt based on and that. And this is the state C. And once you do complete the charging process, then you will again reach to state B, which is the 9 volt. And once it is not charging, even if you connected it, so maybe you will remove the plug, then at that moment you will again reach to state A. So this is how the entire process looks like. So basically here you unplugged the charger, you plugged in and you charging, and then you are again plugged but not charging, and then you remove the plug. So this is how the entire process looks like, and that is how the circuit is able to detect through the help of this control pilot. And if you see over here, right, there is a more wide pulse here in this point, and then there are narrow pulse here. So basically what it is telling, it is basically controlling the current that is flowing through the conductor. So it is signaling that here, suppose it is 50% of the duty cycle. So whatever the maximum current that is decided from the EVSC and the electric vehicle, 50% of that will be transmitting through the conductor, which is the charge carrying conductor between the charger and the electric vehicle. But suppose you already charging too much, and now you reach to the desired limit. Now you want to charge it slowly. Then in that moment, suppose you are doing to, like, you want to charge it at 30% rate. So again, the current will reduce. So by changing this pulse width, right? So basically you are able to control the current through the control pilot, and you are allowing that much amount of current so that it will not damage any of your equipment in the electric vehicle. And that is how this charging process happens. So this is the summary of how the charging process happens in this entire process. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead and happy learning MATLAB. Thank you.